Okay, so today we are going to start with another new chapter. So we are at our chapter 3, which is coordinate geometry. All right, and then I believe that most of you learned coordinate geometry before, and then there's nothing new also for this part. So generally the syllabus is very similar to what you have learned. All right, just that maybe you need to try to understand the A-level style question only, no? All right. Mainly all the formula, all the details that you learned previously in secondary school, okay, it is still applicable here. All right, they are still the same. So for this chapter, generally it's quite short, and also we will take a very short time to complete this whole chapter here, right? Okay, so let's start with our chapter 3. Okay, let's have a look for the learning outcome 3.1. So what are the basic idea and concept that you need to have after you go through with this video? So first you need to know how to find the length, how to find the gradient, how to find the midpoint of the line segment. Okay, if let's say we give the coordinates, right? So there are three important things here: length, gradient, midpoint. Okay, and after that, they want you to understand and use the relationship between the gradient of parallel and perpendicular line. So for gradients, right, sometimes we are having the parallel line, we are having perpendicular line. So what is the relationship between of the gradient between these two types of line? Okay, and after that, you need to understand the relationship between the graph and its associated algebraic equation, and use the relationship between the point of intersection of graph, okay, and the solution of equations such as or this one you learned before already lah, like when a line being a tangent to a curve, or when the line is have two intersection point with a curve and so on. All right, so this one actually you learned in chapter 1 before. Yeah, so for now the basic one is you need to know the length, gradient, midpoint, and then parallel gradient, and also the perpendicular gradient. Okay, so I will go through quite fast because all the examples here are quite basic. All right. Okay, so let's start with the first one. Okay, so first you need to know what is the meaning of Cartesian plane, or coordinate system. So when you write our coordinate in x and y, so we call it as a Cartesian plane or coordinate system. So x-axis is the horizontal line, y-axis is the vertical line, origin is the 0, which is the point of intersection for x and y-axis. Quadrants, there are 4 quadrants, okay, in our graph. So generally the number of quadrants is the same, like what we have in trigo. Okay, so this is all you have for the basic definition. Okay, then after that, first, let us remember what is the formula for distance between 2 points. So to get the distance or length between 2 points, okay, so generally what we need to have here is AB is equals to x squared, x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root. So this is generally the formula. So if you want to know how the formula comes, you can refer to here. I'm not going to discuss it here, so you can have a look yourself. All right, so generally this is the formula that you have to memorize: x2 minus x1 square plus y2 minus y1 square. Or you can memorize it as x1 minus x2 square plus y1 minus y2 square, also can, no problem. So the first thing you need to know distance also, or maybe the length of 2 points, okay, or distance between 2 points. So this is a basic formula. Next, what is the formula for midpoint? So midpoint means the center point of a straight line between the 2 points. So if let's say you're having 2 points here, x1, y1, x2, y2. So to get a midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by. So this is also very basic. All right, so just make sure that you try to memorize it or remember it. I think all this you can memorize, right? Because you apply it quite often. So should be no problem for you to memorize it. Okay, then after that, followed by the next one, we need to know how to calculate the gradient. So for the gradient, the standard symbol is m, and then we see y2 minus y1 divided by x2 minus x1. Or you can have y1 minus y2 divided by x1 minus x2. But you cannot change the sequence. Like you cannot change something like y2 minus y1 divided by x1 minus x2. This is wrong. Okay, you have to follow the point that is matching each other. So y2 comes first, then at the bottom x2 comes first. Okay, so this is the formula for gradient. Again, you will need to use it very, very often. Okay, so now there are some questions that they might ask you about the gradient. Okay, so there are a few types of gradient that you should know. There are some rules that you need to know also. Okay, so first, when you are having a straight line that is parallel to the x-axis, then that means your gradient is equals to 0 for this case. Okay, and then when your line is parallel to the y-axis, that's the gradient. So the gradient is equals to infinity. When the gradient is equals to infinity, okay, so when the gradient is equals to infinity, maybe you need to take note on this. Gradient is y2 minus y1 divided by x2 minus x1, right? And it is equals to infinity. How can I get something, a value which is infinity? Like? So no matter what's the value on top, right, to get the infinity, you have to make sure that this value is very, very small. Okay, so the denominator is very, very small. So that a number divided by a very, very small number, you'll get a very, very large value, which is infinity. So when we assume that x2 and x1 is very, very small, generally it is not wrong that you write out like this, x2 and x1 equals to 0. Okay, so this is something that you need to know. When you have a line parallel to the y-axis, gradient is infinity. And also, if you look further into the formula, right, to get infinity, the denominator must be very, very small. So you can also write as x2 minus 1 equals to 0 or very close to 0. Okay, so these are two important things that you need to know. Okay, if gradient equals to 0 and gradient equals to infinity. So why do you need to know all this? Is because of, especially this one, because the m equals to infinity, you cannot get it by using calculation. You'll get math error in calculation. All right, so you have to memorize it manually. All right, cannot just fully memorize the formula. You cannot get it from the formula. For this one, you can get it from the formula. Okay, but generally, when you are having a line parallel to x-axis, then it is equal to 0. Okay, so this is special. So just make sure that you remember this. Okay, then now, if let's say I'm having two straight lines that are parallel. Parallel means that in the same direction. Okay, or parallel means they will not touch each other, they will not intersect. Okay, the distance from two lines are always the same, so we call it as parallel. So when you're having two straight lines that are parallel, then that means the gradient are the same. So that means if the line 1 and line 2 are parallel, that means the gradient 1 equals to gradient number 2. Okay, so if let's say two straight lines are perpendicular, so perpendicular means 90 degrees to each other. Okay, so 90 degrees to each other, what will happen? So you have to remember that the gradient number 1 multiplied with gradient number 2 equals to negative 1. So these two idea and concept, right, it is very important also because they will want you to very often. Okay, so parallel means M1 equals to M2. When two lines are perpendicular to each other, that means it is M1 times M2 equals to negative 1. Okay, and after that, furthermore, you will have something like this when you're having two lines and cut each other, or we will call it as the intersection point. I think this one you should know, right? Okay, and then to find the intersection point, you need to solve simultaneous equation. So this is basic concept that most of us should know. Okay, next. Okay, so no more. So these are some very basic idea about the all the details about the coordinate geometry, like the length, gradient, okay, and so on. All right, so maybe we can try to discuss some questions here. Okay, all right, so let's have a look for example 1. They give you a curve, they give you a line, and they want you to find the distance between the 2 points. So what are the points here? They are the intersection point. Okay, so to get the intersection point, what should we do is you have to solve simultaneous equation. Okay, so how can you solve it? Maybe you can pause the video here first and then you try to find out the intersection point yourself. Okay, before you check for the answer. Okay, so maybe y squared equals to 12x. So I will make this as the first equation. Okay, and after that I'm having 3y equals to 4x plus 6, and therefore I'm having y equals to 4x plus 6 divided by 3. This is my second equation. Then I can sub second equation into 1, and I'm having 4x plus 6 over 3 squared equals to 12x. Okay, so you can try to expand everything if you want. Okay, so if you try to expand everything, then you have 4 squared is 16, 16x squared plus 48x plus 36, then divided by 9 equals to 12x. So this is what I have here. And then if I try to simplify everything, I'm having 16x squared. Then you take 48 minus 12 times 9. So you have negative 60 plus 36, and it is equals to 0. Then divided everything by 4. Simplify, so 4 squared minus 15x plus 9, and it is equals to 0 also. And after that, you try to factorize it if you want. Okay, so maybe when I try to factorize it, I'm having 4x 3x here. So that I'm having negative and negative. Okay, just nice. So I'm having x equals to 3 over 4. I'm having x equals to 3. Okay, all right. So you have two coordinates of x. That means these are the two intersection point already. But they want to have the distance between the two intersection point. Okay, so we continue further. When x is equals to 3 over 4, okay, so what is the value of y? So you can substitute it into either one. So for me, I'll suggest you to substitute into the linear equation. Okay, so when you have x equals to 3 over 4, right, then your y should be equals to 3. And then when x is equals to 3, then the value of y is 6. Okay, so substitute into the second equation. All right, so once you have the coordinate already, they want you to find the distance between these two points. So what's the distance here? Okay, so you can take x2 minus x1. So 3 over 4 minus 3 squared plus y2 minus y1 squared. So if you continue from here, you should be able to get one answer, which is 15.4. You can keep it in the fraction form, or you can change it become decimal place, which is 3.75 also can. All right, so this is the distance between the two intersection points. You have to find the intersection point first, then only you proceed with the distance formula. Okay, so you can see this is a partial question, and it is not hard. It is quite simple actually. All right. Okay, then let us continue further. Let's have a look for example 2. Okay, so this is what I have for example 2. Maybe I can make it smaller here. Okay, so what do we have in the question? So they give us a figure, and there are 3 points. Point A, point B, and also point C. Then they say point D is such that line DA is perpendicular to AB. Okay, so this is the first information that they give, DA perpendicular to AB. And then after that, DC parallel to AB. And after that, they want you to calculate the coordinate of D. All right. So again, D, I don't know. So I will label it as X and Y first. Okay, then I will start to focus on the information that they give us. So I'm having DA, which is perpendicular to AB. If DA perpendicular to AB means that your gradient of DA multiplied with the gradient of AB, what's the value that you will get? You will get a negative 1. So I try to apply the information that they give us. Okay, I try to see what formula can I get it from here? Okay, so what is the gradient for dA? So dA means y minus 8 divided by x minus 3. dy, okay, the gradient of, the y coordinate of d, so minus 8 divided by x minus 3, multiply with the gradient of AB. So AB means you can take 8 minus 2 divided by 3 minus 6, and you get it equals to negative 1. Okay, so if you try to simplify this, you have y minus 8 divided by x minus 3. Okay, multiply with 8 minus 2, what do you get? You get a 6. This one you get a negative 3. So when you try to simplify, you should have negative 2. And it is equals to negative 1. Okay? And then what else can you do now? You can try to keep y minus 8 with negative 2 together, and then negative 1 with x minus 3. That means you bring the denominator up to the other side. Okay, and then if you try to simplify, you should have 16 minus 2y equals to 3 minus x. So if you prefer, right, you can actually change it become something like this. If you want, you can change it become x equals to 2y, and then 3 minus 16, you get negative 13. Okay, so from the information given, I get an equation like this. I got x and got y, which is the coordinate of d. X and y are the coordinate of d, right? But I cannot solve the equation here because I have only one equation. So I will just label it as first equation. Then that means you will get another equation from the second information that they give you. So the gradient of DC equals to gradient of AB, parallel. So the gradient of DC should be equals to the gradient of AB. Okay, so what is the gradient of DC? So if you write the formula, gradient of DC will be y minus 10 divided by x minus, y minus 2. Okay, so it should be y minus 2 divided by x minus 10. And it is equals to gradient of AB. So gradient of AB you calculate just now already, which is negative 2. Okay, then continue from here. Negative 2 and then x minus 10. Alright, so I'm having y minus 2 equals to negative 2x plus 20. Okay, so I will assume that y equals to negative 2x plus 22. So this is my equation. And then I can try to solve the simultaneous equation. So I will sub equation number 1 into 2. Therefore, y is equals to negative 2, 2y minus 13 plus 22. Okay, so if I didn't do any careless mistake and you try to solve it right, I'm not going to show you the detail. So you try to solve it, you should get the coordinate of D, which is 6.2 and also 9.6. If I didn't do any careless mistake, right? So please correct me if let's say there's something wrong in the steps here. Now, so again, you need to know how to apply the relation, okay, between the gradient and also to apply the formula for the gradient relation, okay. And then after that, you get two equations here, right? Then you use it to solve for the coordinates of D. Okay, so I didn't show you how you solve it simultaneously, so hopefully you can do it yourself and try to see whether you get 6.2 or 9.8 or 9.6 or not. Okay, so again, the question is not hard. Then if you look at the label here, it is also one of the past year questions. All right, so if no problem, let's continue with another example. Okay, so example 3, they are having 3 points here and a 3 points here belongs to the vertices of triangle. Okay, and then there's a point H lies on the altitude truth A. Find the relationship between A and B. So maybe you don't know what is the meaning of altitude here, so I will just tell you straight away. Okay, I'm having a triangle. You can simply draw a triangle, no need to bother about it. What kind of triangle you need to draw? So you have point A, point B, point C. Just simply label it, will do. Okay, you don't need to purposely go and sketch it nicely. Okay, according to the coordinate, no need. You just roughly sketch a triangle with all the vertices. Okay, and then after that, what is the meaning of lines on the altitude truth A? Okay, so generally, the altitude means that I'm having a line pass through A, and it is 90 degrees to the length opposite of it, and then the H should be here. Okay, so this is the H. All right, so if you go and look for the definition of altitude online, then you should get this also. Okay, all right, so altitude truth A means that you're having a line pass through the A, and which is 90 degrees to the length opposite. So the H lies on the altitude of truth A. Okay, then what can I do for this one? They want you to find a relationship between A and B. Okay, so maybe the H, the coordinate for H is A and B. Okay, so if you look at this figure, you know that AH and BC are perpendicular to each other. So what I can do is that I'm going to use gradient of AB multiply with the gradient of BC. Oh, sorry, not AB, AH. Okay, then multiply gradient of BC equals to -1 because they are 90 degrees to each other. So maybe some student will ask me why I don't use BH or maybe CH, but I want to use BC because they should be the same, right? Okay, if you use anything with H here, like BH or CH, right, later your example that you get should looks more complicated because you got coordinate A and B. And then here also got coordinate A and B. So later when you want to simplify it, might looks like a bit harder or a bit complicated. I never tried before, but this is what I think. So if you want to try, you can have a look, have a try. Okay, so I just stick to the BC here. Okay, so what's the gradient for AH? So you're having B minus divided by A minus 2. And then it is equals to the, multiply with the gradient of BC. So what's the gradient for BC? You have -2 minus 3 divided by 1 plus 2. And it is equals to -1. Okay, so if I continue further, I have B minus 4, A minus 2, multiply with -5 over 3. And it is equals to -1. Okay, so if you try to rephrase everything, try and see whether you can get 5b equals to 3a plus 14 or not. Just try to rephrase everything. So this is the final answer that you should get. Because here they only say find a relationship between A and B. So when you get an equation in terms of A and B, that means this is the relationship between these two values already. Okay, so 5b equals to 3a plus 14. Okay, so for this example, what I mainly want you to know is the word altitude, how you express or how you actually try to sketch the altitude in the graph here. Okay, so you will see that these three examples cover the basic idea that we learned just now. All right, so I will stop here for this video, and then the next video we are going to discuss how to form the straight line equation. That's the first thing, how to find out the shortest distance, okay, and how to find the area and so on, that we are going to apply in the exam style question also. All right, so I will discuss all this in the next video.